In this video, I want to talk about the idea of phase shift for the graph of a trig function. Let's start by considering the graph of cosine of x minus pi over 2. Recall from algebra that if you take a function, in this case cosine of x, and you substitute x minus pi over 2 in for x, then the effect is to shift your graph to the right pi over 2 units. So that's all that we have done with this function. We haven't changed the period at all. We haven't changed the amplitude at all. All we've done is shifted to the right 2 units. I'm sorry, not 2 units, but pi over 2 units, right? So to graph the function, before I would think about starting at 0, 1, but now since I've shifted to the right pi over 2 units, my first cycle is going to start at pi over 2. I haven't changed the period at all. I'm not multiplying x by any number, so the period is still 2 pi. Pi over 2 plus 2 pi is 5 pi over 2. So there is where my first cycle is going to exist. The period is 2 pi, so the quarters are going to be 2 pi over 4, or pi over 2 units. So pi over 2 plus pi over 2 is pi, plus another pi over 2, 3 pi over 2, plus another pi over 2, 2 pi, and then another pi over 2 gets me to 5 pi over 2. So these are the intervals for my first cycle. Put in my amplitude lines at y equal to 1 and y equal to negative 1. And this is the cosine graph, so I'm going to start positive cosine graph, so I'm going to start up at 1, down to 0, down to negative 1, and back up. So there is the first complete cycle for this cosine curve. And of course, this cycle is going to repeat in both directions out to infinity. Okay. So pi over 2, since this is where the first cycle begins, is what we'll call the phase shift. Okay. And a nice way to find the phase shift is to take your argument, in this case x minus pi over 2, set it equal to 0 and solve for x, right? Because when this expression is 0, right, I have a 0 there. Cosine is seeing 0, and it's going to think to itself, okay, let's start the first cycle. So if I take my argument and set it equal to 0 and solve, then I'm able to easily find the phase shift for the function. So let's try another example. Let's try cosine of 1/2 x. And let's do minus pi over 2 again, right? So because of the minus pi over 2, we might think that the phase shift is still pi over 2, but we've multiplied x by something as well, and that is going to change, that is going to alter our phase shift from what we might naturally think, right? Ultimately, we want to know, when is this argument 0? Because when that happens, that's when our first cycle is going to start. So I'll add pi over 2 over. Oops. And then multiply both sides by 2 to get a phase shift of pi. Right, so my first cycle is going to start at pi. The period, we're going to take 2 pi. We're multiplying x by 1/2, so it's going to be 2 pi divided by 1/2. The period is going to be 4 pi. Right? And the amplitude, I haven't done anything on the outside, so the amplitude is still 1. So with this information, let's go ahead and graph this function. Alright, so the phase shift was pi. The period is 4 pi, so I'm going to go all the way out to 5 pi. Take the interval and chop it into quarters. Well, 4 pi divided by 4 is just pi. So I'm going to keep adding pi to get my subintervals. I'll put in the amplitude lines. And now, since my phase shift was pi, my first cycle starts there. So I'll start up at 1, at pi, down to 0, down to -1, and back up. So there we have one cycle of this cosine curve, and of course that cycle continues or repeats in both directions.